Welcome back to part three, right? Yeah, this is part three, I think. So let's continue with the practical assessment. So this practical solution builds upon the Matrix 2D class you created in whatever, blah, blah, blah. We've created that. We are done. So now the first question, okay, the first thing that they've stated is that the constructor and the destructors, there's no changes. You don't put any changes there. Accessors for the number of rows and columns, you don't change them. The things that you must add, yeah, the things that you must add is the object to another object. So you should be able to assign an object from one object to another. So you should perform a deep copy. So we have been copying the matrix. Remember the copy constructor, the lazy builder, the one who's copying other people. There he is. We have been copying. But this was a shallow copy. It's a shallow version of it. As you can see, it's a shallow version. It's not the proper version of copying. Now we're gonna do the proper copying. So before we do that, let me do this. The library za.se. Okay, this thing is taking its time. Let me just open the slides here. But I don't want to open the slides. I want to download this book. Okay, this is the one. Okay, it's loading. Okay, I'm signed in. I want this one with this cover. Yeah, this is the one. Okay, save. Just shut up, man. Hey. Um, let's download this one so that we can check the reference or the approach that we have to overload the operators. That should download anytime soon. Come on, just download, man. What do I want to check? So assignment, blah blah blah. With the assignment, let me see. I think with the assignment, it should return the reference, the object reference, if I'm not mistaken. Yeah, I think it should return the object reference. But let's just wait for this thing to download. Then we check. Because when you assign one object from another, you must return the object itself. Because this is an assignment, right? So after assigning, I must return myself. Yeah, I must return myself after assigning. What do I mean by assign myself? So basically it's this. When you say x is equals to 2, I'm a, that means I get back x, but x now has this value. So when I say y is the formula x plus 2, then I would know that, oh, x is a placeholder for 2. So instead of x, I just put 2 there. 2 plus 2 now becomes 4. And then now y has the value of 4. So that's what I was saying. So let's open the book. Downloads. So since I don't have Adobe, this is gonna be, I should have just downloaded Adobe. Let me see if I can't navigate. Okay, it's gonna be quite a problem, but let's see. Where's the operator overloading? It should be somewhere. Simple data types, namespace, and the string type. That's not it. Operator overloading. Class scope functions, invoking a constructor, blah, blah, blah. Inheritance and polymorphism. Pointer, abstract class. Operator, new operator, delete, dynamic arrays. Overloading templates. Yeah, this is the one that I want. Page 893. 893. So there we go. Let me do this. So let's see how we can overload this. So the first question that you might ask, okay, why are we overloading? What is overloading? And I don't get it. Overloading is very simple. Remember what I said, when you create a class like this, let's say person class, right? You're defining a data type. In a way, the class keyword, what it's saying, it's based in simple terms, it's saying create a data type named person. That's what the keyword class does. It's like telling the compiler to do so. So you're creating a type named person. So now I can use that type named person like this and create a variable of that type that I've created. So that's what we're doing. So with the same thing, with the same abilities that other types have, for example, integers, you can say int a be like this, right? And then let's say a is equals to 10, b is equals to 100, and then sum. So now, in order for me to calculate the sum, I'll just say sum is equals to a plus b, like this. Look at all of these operators, equals, assigning. So the integer type has the ability to use the operator, assignment operator. It also has the ability to use the plus or addition operator. How do I know? Because as you can see, I'm using it. And how do I know? Because what's on the left is an integer and what's on the right is an integer. So we need to be able to do the same thing with our type called person. So I should take a person object and then add it to another person object. I should also be able to do all of these things. That's what we're trying to do with operator overloading. I want to be able to do the very same thing that's being done here. When I say a plus b, I want to be able to do that with this person data type. So that's the main goal. So we're gonna do that now. So the first operator that we must overload, let's see. Let's check what's the first operator. It's the assignment operator. The assignment, it's either it returns back the object itself or a reference. So let's see. Yeah, this is the formula for an operator to overload an operator. So the formula is like this. You have you're basically creating a function. This operator is a function. This is a function. By function, I mean the function that you guys know. So the formula is that you create a function in this structure, in this following manner. You have a return type. The return type is just the data type. It can be void, int, whatever return type that is. And then operator, you use the keyword operator to specify that I want to use the plus or the divide or the times to multiply the objects or the index operator, square brackets to index. I can do all of this thing, or the assignment operator. I can do all of those, or the stream insertion, or the stream extraction. So I can do all of those things. So I specify, let's say I want to overload the stream plus operator, and then I take in what parameters, and then that's it. That's the formula. And the parameters depends on the operator that I'm overloading. For example, if you look at this plus, I would have to take in two parameters, a left-hand side and a right-hand side. What do I mean by left-hand side and right-hand side? Look at A and look at B. The operator is the thing that's in between them. So as you can see, A is on the left-hand side, B is on the right-hand side. So that's what I mean by this. So you have what's on the left-hand side, and then you have an operator that's operating on this operands. So left-hand side and right-hand side, those values are called operands. So A is regarded as an operand, and then B is regarded as an operand, and then the plus is the operator that's operating on the operands, and this whole thing together, this one line, or this one line, is called an operation. Like for example, a doctor's operating a person, it's an operation. So it's the same, it's sort of like the same concept here. That's what's going on. There's an operation that's being done. What's the operation? It's the plus addition. So I'm adding this, the left-hand side operand, and B, the right-hand side operand. And then I get back a value. And the return type, it depends on what you're getting back. If you check here, what am I getting back here? After adding, what do I get back? Let's just double check. So remember, these are just placeholders. A and B are just placeholders, are just variables. So 100 plus 10 plus 100, that gives me 110, right? So what is 110? That's the question. 110 is just an integer. So that's why I'm able to use the equals sign, because it matches. Remember what equals means. It means what I have on my left-hand side is the same as what I have on my right-hand side. In this case, we have the sum on the left-hand side, which is an integer. What do I have on the right-hand side? It's the value 110, which is of also type integer. So in essence, int is int. That's what's going on behind the scenes. It might look like I'm over explaining, but that's exactly what's happening, so that you get it in a very simplistic way. It's very simple, this thing. Don't try to overthink it. What you're getting back is the type itself. So that's exactly what you're going to do. So in order to declare this operator, the assignment operator, let's look at the assignment. So with the assignment operator, remember, we're going to start with the assignment. So the assignment operator, they said you should perform a deep copy. So basically we are copying. This another thing. We are copying, so we're going to be repeating this code that we have in the copy constructor. And we're going to repeat the code that we have here at some point. You're going to see this code, you're also going to repeat it. So since I'm going to repeat this code, these two things, I'm going to create a function instead of having to repeat myself. Both of these functions are going to be of type void. So I'm going to have a constructor. I'm going to call it constructor. That's the first function for allocating. It takes in 3 integers. And then I'm going to have a destructor. Remember, the destructor doesn't take in anything. There we go, done. And then void copy constructor. The copy constructor is going to be the same syntax as this. I'm doing this because I'm going to be repeating a lot of code. I don't want to be repeating. I just want to reuse. And remember, the copy constructor is not meant to change. So I'm going to put the const keyword at the end, just to make sure that it doesn't really change. I need to have that level of security there. And then I copy this functions or these helper functions. These are what we call helper functions. Why are we calling them helper functions? Because they are private functions. They are not public to the user. So they're just going to help work as helper functions to help us reduce our code. So what I'm going to do now, instead of writing the code for the destructor and the constructor and the copy constructor, I write it inside functions and then I call those functions instead. So like this, I copy this, cut. That's for the copy for the allocation part. And then I need to give it names. So rows, columns, and value, right? That's exactly how I had named it previously. Then I'm going to have matrix 2D specify that it belongs to that class. Then now, once I've created this function, I called it a constructor to help me ease up I ease up this thing of having. I don't want to have to forget what I call the functions. I know it's meant for constructing or building, so it's called a construct. So I call that function instead. What this function does, remember, whenever you call a function, it just copies and pastes the code. That's all it does. The same thing with the constructor chaining. It does the same thing. When you call a function, it just copies and pastes the code. But then you specify, when you copy and paste the code, you pass in the values that will be used to represent those values in your code. And then I copy for the copy constructor here, and then I go down to my function that I've given the name copy constructor. And then bam, there we go. And then obj matrix like this. And then I'm gonna have matrix 2D scope resolution that I bind it to my class so that it knows where I'm getting this function from. I'm getting it from my class, or I'm telling it to take this code and bind it to that function that I've declared inside of that class. Then we have the destructor. I'm just gonna cut this and then call the destructor instead, like this. And then destructor, done. So now I don't have to copy and paste the code, or I don't have to write it from scratch. I just call the functions when I start implementing operator overloading. So that's fine for now. Now we need to get to this side. And then here I'm gonna write operator overloading. So let's start with the assignment operator. With the assignment operator, with the assignment operator, they say that assigning an existing matrix 2D object to another matrix 2D object, overloading the matrix assignment operator. So we're just basically assigning. Remember, it's the assignment operator. It's basically me saying x is equals to 7, something like this. That's what we're trying to implement. But I'm not gonna be assigning it to a 7 anymore. I'm assigning it to another object. So now I'm gonna be okay. Let me just write it like this. So now I'm gonna have, let's say, obj matrix and assign it to another obj matrix. Let's say matrix 1, and then it should also allow for chaining for me to also do this. Matrix 2, something like this. You should also allow me to do this. So that's what you're going to implement now. So that's what you want to do. In a way, you can imagine that, let's say they want to just, you could do this 7. So I say y is equals to 7 first, and then once I'm done, I say x is equals to y. So I assign the 7 into y first, and then that y value, I assign it to x. So that's what we're trying to do. That's what the chaining is. So you can do it in two ways. You can chain it like this, or you can just leave it like that. So that's what you're trying to accomplish here. That's what they mean here when they say obj, we should be able to chain it. Do they Okay, they didn't explain it, but yeah, you should able to chain it like that. So let's do that. So with operator overloading, remember the formula is the return type. So what am I getting back? Remember what he said. This sum is equals to 11. It is true because sum on the right hand side is an integer. And then the 11 is also an integer. So basically int is equals to int. So this statement holds, it's true. Remember that equals is what the equals means. It means whatever I have on my left hand side is the exact same thing as what I have on my right hand side. That's the first property of the equal sign. The second property is for you to take the value on the right hand side and store it inside a variable that's on the left hand side. So let's do that. So it should return a matrix 2D. I think it should, it's either matrix 2D reference or just matrix 2D. Let's just double check. Let's look for the operator. It's either pointer, it's either dereferencing or something else we're gonna check. Mm, Where's this formula, the templates? Mm, let's see. There's so many examples. Operator overloading as non-member functions, blah, 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 blah. Binary operators, I don't want to overload those. Let us overload, blah, 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 not equals to. I don't need that. I need the assignment operator. Mm, what is this thing? Yeah, this is the assignment. This thing is a lot. Let me see. Okay, yeah, it's a reference. I thought, okay, it makes sense because you need to get back. Reference is faster. Yeah, it's faster. So the reference is faster. Let's just double check. Const, which is fine because we don't want to change the object. So I'm gonna put const here because I don't want to change the object. And then I'm gonna put the address of so that I get back the address instead of the object. But I don't want to get it by value because it's gonna be slow. And then I say operator. There's the keyword operate, and then it highlights what operator do I want to override or that I want to overload. Is the assignment operator, which takes in, remember the formula for copying. It's a const what? Matrix to the reference. So it takes in a const matrix to the reference like this. That's the formula. Then now I'll be able to use the assignment. I can copy objects, but then it won't be a shallow copy. It's going to be a deep copy. So let's do this. And it is a member function, remember? It's a member function. So what if I define, what's the name of the function? This is the name of the function. The keyword operator plus that symbol. So it's always before operate. That's the name of the function. So there we go. I have const matrix to dereference. That's going to be returned, right? So let's do that. So before we assign, we transfer and do all of these things. Let me do something. So check if I am not already the right-hand side. So before you do all of this, make sure that you're not already the right-hand side. What do I mean? So let's say you're trying to say, let's say x is equals to 3 and y is equals to 3. The way to avoid this, let's say I wanted to take the y value and make it my x value. I make sure that I shouldn't have I shouldn't already have the same value as my y before I try to assign, because it's gonna be a waste. I just skip that process of copying. I just skip it entirely and then just return x value because they are the same. As you can see, x and y are actually the same. It's 3, 3. So it, instead of it doing this, what it does, it skips this whole process of going to y and then look for the value of y and then come back here and give me back y. It avoids all of that process. And I'm gonna show you right now through an if statement. So what's gonna happen now is I'm gonna check my y value. Instead of checking the y value, I return the x. I just return x as it is. So it returns x. What is the x value? Is 3. That's it. Fast, done. I don't have to go to y and deallocate what to others. It's going to be a long process. I just return back myself because we are the same. We have the same content. So how do I do this? How do I do the deep copy? The deep copy works in this way. So I say if, okay, I give it a name. I say obj right hand side, because my current, remember the current object is the one that's always going to be on the left hand side. What do I mean? So for example, when you say matrix 2D, obj matrix, and then I'm going to have obj matrix 1, something like this, right? So what's going to happen is that this is how we're going to use the assignment, right? So matrix obj, let's say I'm trying to assign obj matrix 1 into the obj matrix object. So I'm going to do it like this. Obj matrix 1. So as you can see, my current object is already on the left-hand side. It's already left-hand side. So by default, whatever I'm taking in, this one is what's on the right-hand side by default. So that's why I'm saying this object that I'm taking in, it's what's on the right-hand side. So now I'm gonna check, right? How do I check? We check by means of addresses. So I say this, which is me, what my left hand side. Make sure that my left hand side is not equals to my right hand side. Make sure that condition is met. How do I check? I check by addresses to make the things faster. I only check the address. It's gonna be very fast. It's gonna check. Let's say it's 33 Hampton Avenue, right? And then that's my current object. That's what this operator stores. And then let's say the other object, this one, the right hand side, it stays. Let's make an example. Let's say it also happened to stay at the same location, Hampton Avenue. That's obj right hand side, right? And remember, this one just basically represents my left hand side, which is me, my current self. So what's going to happen is going to compare the addresses. Do they match? If they match 33 Avenue, 33 Hampton, 33 Hampton Avenue, then it skips. It just checks the addresses, which is going to be very fast because I just check the address. I don't need to check the thing itself, the object itself. I just check the address. Do the addresses match? No. If they don't, then I can make a deep copy. If they do match, then I shouldn't. It's already the same. They already have the same values, so there's no need for me to copy to perform the deep copy. So it's the same thing. That's what's going on here. Remember that this operator, it stores the address. This operator, it stores the address of my object. And then when I dereference this, when I point this Point. Remember, point means to point that person. Remember when you raise your finger and you point at something, what are you pointing at? That thing, right? So in a way, that's the concept behind the pointers. Like point when you point to something, or when you point to that address, it means go to that address. So this means go to the address, which means that you actually get the object itself. So you actually get the object by dereferencing. So just keep that in mind. So I'm going to compare it by addresses because it's faster. I don't want to compare it by value. If I compare by value, it's going to be a very big problem. It's like, for example, trying to compare two people if they stay at the same house. That means I'd have to go at each individual person's houses and check each utility. I check the microwave. I go and check the other person's microwave and check if they match. Then I go back to that first house and I check if their bedrooms, check the bedroom. I go to that second person's house. I check if that bedroom matches with the first person's bedroom. So you see, I'll go up and down. I'm wasting time. I'm wasting resources. I'm wasting space. We don't want that. I want to just go check the address. Is the address the same? If it's the same, then obviously it's going to have the same exact same things. Done. I don't have to worry about many other things. So I check if this address, my current address, which is accessed through this operator for this keyword, is not equals to the address of the other object, obj right hand side. Make sure that's the case. Don't assign if they're already equal. If they're the same address, it's gonna skip this whole process. So how do you assign? Let's check. You start by destroying the object. So you make space or destroy whatever was there to empty it out. Make sure it's not in existence. You destroy it. Then you construct. You build it. Obj right hand side dot underscore rows, and then obj it's what obj right hand side dot underscore calls. You allocate it, right? And then I'm just gonna use the default value here because it doesn't really matter. I'm gonna destroy it either way. Doesn't really matter. So what I'm doing here is that I'm making sure the objects are equal. This matches to my rows. What are my rows? It's underscore rows. That's the value of my rows. So I make sure that this it matches with that object. They match with each other. And then after they matched, then now I can what? Copy. I make sure that they're of the same size. Copy constructor. Copy what? This object. And then done. This is the 3 steps that you need to take. You start by destroying. You clean, make sure it's clean. And then allocate memory. And then you copy the data that you want to copy. And then once you're done, you return yourself, right? You're supposed to return an address, right? So in order for us to get the address, we're supposed to dereference. So you must go to the address like this, return the values of the object itself, like this. After returning the object itself, it's going to get the address of that object that you've returned. If you return the address now, it's going to be a problem. It's like, okay, I must get the address of an address. It makes no sense. That terminology makes no sense. So now when you return the object as it is, it's going to get the address of that object, which makes perfect sense because that's what you're trying to get, the object itself. And then I refresh, and then as you can see, there it is. And then done. We've copied the object. Everything is fine. Let's just double check the implementation. Yeah, this is exactly how it is. As you can see, we compare by address. So you make sure that you avoid self-assignment. I don't assign myself, I don't assign the same value that I already have. In essence, I'm assigning myself to myself. You get what I'm saying? It's like I'm saying X is equals to X in a way. So that's what self-assignment means. So X is equals to Y, is equals to 3, right? And then y is equals to 3. So when I say x is equals to y, in a way, I'm saying x is equals to x. I'm assigning myself to myself, of which that's something that doesn't make any sense. I'm trying to avoid that by checking whether it's already the same value. By checking the addresses. If this address matches to the address of that other object on the right hand side, this is the one that's on the right hand side. If it matches the addresses, then skip. It's gonna skip all of this. But if it doesn't match, then implement what's within the if statement. So we are done with that. Let's test it out. So I'm gonna write this testing assignment operator. So let's test the assignment operator. So how do I test? I create another matrix and try to copy obj matrix 1, right? And then obj matrix 1 must copy obj matrix. So let me say obj matrix like this. There's the assignment operator. Let's see if it's gonna complain. It won't complain because we did write the code. And then now I'm gonna output the matrix, right? So before I do that, I'm gonna output this so that the person who's using my code can understand what's going on. So I'm gonna say testing assignment operator. And then end line. Instead of me just displaying text, I need to put a heading so that it makes sense what am I doing there. Dot to string and then end line. And then run. And then it should be exactly the same. Yeah, there's a bit of a problem here. Let's see. Oh, I think I know the problem. Let's see. I think they made a very big flaw. It's this const. You see this const here. That's the const that's preventing us from changing this. So what I'm doing there is I'm saying return. Okay, it is still not okay. That's not the problem. Uh, but that should be the problem. Everything is fine with my code. We avoided self-assignment. Yeah, you see right object, const reference. There we go. Yeah, there we go. Is equals to this. Let me see. Or maybe I didn't assign properly. Let me check. Wait, I did assign properly. But let me just separate the assignment. I think the way I've assigned it. So let me say obj1 is equals to obj matrix. So get the value from here and then put it in there. I'm going to separate those two steps. Yeah, that's where the problem was. So you shouldn't combine those steps. So if you try and do this, combine these steps as declaring and assigning, yeah, it's not gonna work. It works like this. So basically it follows the maths approach. So x is equals to y. Yeah, that it follows exactly like this. It needs to be in this format. Not for you to have some type like this. Yeah, not for you to have that. And then we can also test. Okay, remember that we need to test for obj matrix 2. We need to test what is this, the object being assigned multiple times like this. So we need to test that. So I'm gonna test using that approach. So I'm gonna say obj matrix 1 is equals to obj matrix 2 is equals to this. So I start by taking the value from obj matrix, put it in there, and then I take this value, I put it in there. So if it displays the same objects, the values, then it's working perfectly fine. There we go. It is working perfectly fine. They're exactly identical, and we know that we're on a good track. So what I'm gonna fix something very small. This is too large. I'm gonna make it 10 by 10. Yeah, this should be fine. It's a bit smaller. Yeah, I don't want it to be too big. So we tested the assignment operator. It is working. As you can see, I have more than one assignment. It is working perfectly fine. We did overload the assignment operator. So let's overload the other operator. What's the other operator? The other operator is the function invocation operator. So that it takes in two integer parameters, including the row and the column, and the corresponding value from the underlying, taking two integer parameters. So you must take in two integer parameters, the row and the column. So with this one, let me see. There should be, okay, with this one, you must return the value itself. Tell the, yeah, you must return the value. Was it void? I think, wait, is it void? I think it should be void. I'll just double check. Mm, let's see. How many operators did they overload in here? Let's double check. But then let's see. Let me see the invocation. So the specific index, you should change this to 7. So what I'm thinking is that you won't have to, it doesn't have to return anything. It should be a void. I think you just need to double check. Um, do- let's start at the top. What are these operators? Binary, arithmetic or relational? I don't wanna overload arithmetic or relational. Still arithmetic or relational. Yeah, still them. Come on. Where's the formula? Okay, just give me a sec. I'm still looking for it. Okay, operator symbol. Okay, scroll, scroll, scroll. Point to this. Nope. It's a lot of examples. Friend functions, definition of a friend function. Let me do this. Let me just go back here. Let's check something here. Operator overloading. I think it was at the end though. Towards the end. Yeah, there it is. This operator. It's 950, page 950. Yes, toward the end there. There it is. So, okay, we still use the address, but I think you can just use, let's just do it this way. We need to use the address again because it's faster than getting it by value. So there's two ways. You can declare it with the const like this. That's the first way. You can declare it like this with the const. But with the const, it means that you can't assign. That's the problem. You can't change. Remember the basics. That means I can't say is equals to. I can't do that. So since that I need to make sure that it allows me to do so, I need to remove the const and say matrix 2D like this by a reference. And then I define the operator. What's the operator? It's this one. The function is the invocation operator. And then I do this. So with the second set of brackets, it's mainly for me specifying the parameters. What are the parameters? It's two integers, the row and the column. Yeah, it's supposed to, yeah, the row and the column. Yeah, just the row and the column. So it's supposed to work like this, just the row and the column. Remember that we already have the assignment operator. That's the one that will handle the assignment. Remember when you have to say OBJ matrix like this, they say 1, 2 is equals to 8. The assignment operator is the one that will handle this part. So I don't have to take in a third parameter for this value that's on the right hand side. No, it's going to process it like this, left hand side, right hand side. There's the operator for doing so. So I just need to declare it like this, and then I'm good to go. So let's do that. It's actually very simple to implement this operator. And then int, it's going to be a row and a column, right? It's meant for accessing, right? So all I have to do is just return what the values at that specific index. It acts as an accessor basically. I think it should be like this, but let's just double check. But I think in simple terms, it should be like that. Let's just double check. Yeah, that's exactly how it should be. It should just be like that. So I'm just returning the array. And then another important thing before we forget, it's enforcing the range. Okay, it's not recognizing force range because I didn't do this. Yeah. Okay, I don't have to copy and paste all of this. I don't have to rewrite it. I can just copy and paste. Where's the code? Okay. For this one, I forgot to say -1. If you're starting from 0, obviously you need to subtract 1. That's something I forgot to do there. You need to subtract 1, and then enforcing the range here, then I'm gonna have underscore rows, then underscore columns to make sure that the row and column is in the right range. Okay, I can just remove the S there. Then you're gonna test what is it called? The invocation operator. Testing the invocation operator. Testing that. So how do we test it? Let's test it out. So I'm just gonna say I'm gonna use obj matrix 1 and then give it specific index. Um, let's say the top left corner, so row 00. So remember that you're gonna have something like this, right? For something like this, right? I'm gonna change this coordinate 00, that specific coordinate. So I'm gonna say 00, that's the coordinate, is equals to, that's we are calling two operators, this operator and then this invocation operator. Assign that to 100. It should be very easy to see that this answer or this value should be very easy, because obj matrix 1 dot 2 string and 9, it should be very easy because all of the values are a single digit. So if I put the 3-digit there, then it should, what's missing here? Oh yeah, it makes sense. There's no for integer. 26 is equals to 7. Copying another existing object. The following operation must be possible. Integer parameters indicating the row and column, and returns the corresponding value from the array. The value must be returned by reference so that the same operator can be used to modify the value. Okay, so they're giving you a clue. We do exactly as intended. Yeah, we did do everything perfectly fine. Now the problem is the operator. Yeah, it's the assignment operator that's the problem now, which makes sense because if you check the assignment operator, it took in a matrix. It wasn't taking in an integer. So in essence, we don't have the operator for that, but why would it but why would it complain? It shouldn't necessarily complain. Let me think about it. So it should indicate the row and column and returns the corresponding value from the underlying array. This is perfectly fine though. List 3. Well, the way it's working right now, the way it should be used according to what we have, I shouldn't be writing it like this. Instead, I should be writing it like this. Let's say, for example, obj matrix 1, 1. Instead, I think it should be like that. That's what it's looking for, unless if I didn't return it properly. I didn't return the values properly. But let me see. It shouldn't return. Let's see. It should return a matrix. Yeah, it shouldn't return this. Yeah, this is not correct. The way I did it is not correct because it shouldn't return a thing, array. It should return, it shouldn't return the array. You should return the matrix 2D. So let's just double check that and see what's what do they really want here? So you must take in a row and a column, by reference, and then and returns the corresponding value from the underlying array. The value must be returned by reference. Okay, it returns the corresponding value, not the matrix 2D. So since it's returning the corresponding value, I must say int reference like this. So now it should be fine. Yeah, I didn't pay attention to what they were saying there. Yeah, now it should be working perfectly fine. No issues. Yeah, I should be working fine now. Yeah, I don't know why I did that. It's supposed to work properly fine. Yeah, there we go. Index 00, as you can see, 100. It did change. It's working perfectly fine as intended. I was just returning the wrong thing. They wanted us to return an integer, which makes sense because if you check, you're supposed to get back an integer. We're gonna assign it to an integer, not another object. So I should return back an integer because I'm gonna be working with integers here. And then, so basically this is what happened here. You see what was happening? Before I was returning a matrix reference. Remember that this is not, it doesn't have cons at the end. It means that after returning this, I can use it as, and for assigning, I can do this. So basically this is what's happening. I say is equals to 100, which is fine. So what was happening, the issue was that I was returning a matrix reference. So I was returning, let's say obj matrix, and then I was returning the reference, and I was saying is equals to 100, of which makes no sense because I have an int here and I have an object there. There's no assignment operator defined for this. So yeah, you need to make sure you don't make the same mistake I made. So yeah, that's fine now. So I think I should stop here. I don't want to make it too long. And then I'm gonna make part 4.